Good morning, good afternoon, and good evening, depending on where you are, friends and colleagues. On behalf of Healthy Climate Initiative, I'm delighted to welcome you to today's webinar, SAI and the Monsoon, What We Know and What We Don't. The conversation is both timely and urgent. As we have seen with the devastating floods in South Asia, extreme rainfall events are no longer rare. They are becoming part of a troubling pattern. The monsoon is South Asia's lifeline, yet it is increasingly unpredictable, swinging between floods and droughts. Understanding these changes and exploring potential solutions such as stratospheric aerosol injection is critical for our shared future. We are honored to have with us three distinguished panelists, Dr. Douglas McMartin, Dr. Bala Govindasamy, Dr. Muhammad Abu Sayed. Together, they will help us unpack both the science and uncertainties around ACI and the monsoon. Now it's my pleasure to introduce our moderator for today, Trisha Patel. Trisha is a research assistant at the African Climate and Development Initiative at the University of Cape Town. Her work looks at how solar engineering could influence climate extremes and how those shifts may create both risks and opportunities for societies. With her expertise at the intersection of climate science and socioeconomic impact, she is ideally placed to guide today's conversation. Please join me in welcoming Trisha Patel. Trisha, all
Yes.
yours.
Thank you. Thank you for such a lovely introduction. It's a privilege to engage in such a critical and timely discussion with you today. That being said, the monsoon is more just a system. I think Sumitra has very clearly explained to us it is the backbone of agriculture, water supply, ecosystems, and livelihoods for hundreds of millions of people across South Asia. Unfortunately, we are now seeing signs that climate change is pushing the monsoon system away from a stable state and toward greater unpredictability and extremes. During last year's monsoon season alone, severe floods swept across Bangladesh, India, Nepal, and Pakistan, displacing millions, including over 500,000 people in Bangladesh alone. Over 5.8 million people were affected across several districts, more than 70 lives lost, and damages exceeding 1.2 billion US dollars. And so today we are here to explore two central questions. So firstly, how is climate change already altering the monsoon? How is it shifting its timing, intensity, and risks for people and places? And secondly, what might happen if we were to introduce a climate intervention, specifically stratospheric aerosol injection or SAI? Could this intervention help stabilize the monsoon system, or could it introduce new hazards? So the plan for today's session is to move in steps. We'll begin with a moderated dialogue with our panelists to lay the foundation about what the monsoon is, how climate change is impacting it, what SAI is, and what current research suggests about their intersection. And then each panelist will have 10 minutes to speak more deeply into their own research. And after that, we'll open the floor to your questions and reflections. And on that note, our panelists today are Dr. Douglas McMartin, a senior research associate at Cornell University, who applies control theory to climate systems, focusing on how the design choices in SAI might influence temperature and precipitation. We have Professor Govindsamy Bala, a professor at the Indian Institute of Science in Bangalore and a pioneer in modeling solar geoengineering. His work examines how injection latitude, altitude, and timing could influence the South Asian monsoon. And lastly, Dr. Abu Saeed, a managing director at the Center for Research on Environment and People, and a senior fellow at the Bangladesh Center for Advanced Studies. His work centers on climate impacts, vulnerability, and adaptation in South Asia, especially around monsoon dynamics and flood risk. So with that, I think let's dive into the moderated Q&A. And to start us off, I'll first turn to Dr. Saeed. Could you please give us a quick picture of how the South Asian monsoon works and why even small shifts in its timing or intensity are able to impact water, food, and people's lives at such great magnitude?
Thank you so much, Trisha. So, how do we see the monsoon? It refers to the seasonal reversal of predominant surface winds. That is the regional scale atmospheric land seas surface temperature contrast. And then that contrast, the regional climate variability is ultimately controlled by the differential spatio-temporal variation in solar radiation and associated seasonal contrast in precipitation, particularly in the South Asian region or Asian region. Can you hear me? Hello?
Yep, we can hear you.
Okay. Yeah. So the monsoon, as already discussed, this is the major monsoon system globally and one of the most specular monsoon system in the world. And this precipitation serving as a major water resources for almost all the countries surrounding these Himalayan mountain systems. So it's like more than 1.2 billion people are dependent on this monsoon system. And if from our research, I started studying monsoon in 2011. Since then, what we found uh, due to climate change or global warming, what we see, there is a shift in onset date of monsoon. When it starts the monsoon from the eastern part of Bangladesh, and then it is moving to northwestern part of Bangladesh. So there is a change of almost like 10 to 15 days. So it is coming a bit earlier, one thing. The other thing what we saw is that the total amount of rainfall, this is very important, total amount of rainfall is not changing much. However, the seasonal variability of this distribution of this rainfall is changing. So that during monsoon, there are very number of reduced number of days with rain, and in post-monsoon, we have days with rain, which was not there earlier. So that is changing the whole agricultural practices, or there is a lot of implication in agricultural practices. Another major issue is here, when the number of rainy days is changing, that we are going to experience torrential rain in a small number of days, so which may cost a huge flood or flash floods. That is also again having implication on agriculture and lives and livelihood or assets or infrastructure even. So, and there is another change what we see, number of hot days and number of hot nights is increasing. That is also having a strong relationship with the monsoon system. So this number of hot days increased and number of hot nights increased, having health issues and livelihood issues as well. So this is the major picture, I think, what I wanted to tell you. I hope if you have any query, please go ahead.
No, thank you. Thank you so
One
much for
one thing
explaining.
I may add one thing. Because of this change in South Asian monsoon, I'm talking about South Asia as a whole and Asian region, so that will have a tremendous impact on hydrological process. So the hydrological process, mainly the flooding, as you also mentioned, Trisha, and the amount of discharge each river basin having or experiencing. So that uh, amount of discharge and frequency and intensity of these discharges or floods will have impact on lives and livelihood or asset and infrastructure and all. And this has a teleconnection with the northern hemispheric atmospheric processes. It's not that it is only limited to South Asia, that South Asian monsoon is part of a global atmospheric process. It is not only very regional. Yes, we know that it is a regional process. There is a mountain system, there are ITCZ, there are issues on that, but it is a part of global process. Thank you.
No, thank you so much for explaining how climate change is impacting the monsoon, how it's changing. We've all seen the headlines about devastating floods and heat in the region in recent years. And so maybe from your perspective, looking ahead, could you please speak into what you see as some of the biggest risks on the ground in Bangladesh and across South Asia if these climate changes, if well, changes in the monsoon continue that are induced by climate change?
Uh, what we see, we did two studies in, covering South Asian river basins, Ganges, Brahmaputra, and Indus Basin. What we saw, there is a change going to happen, and particularly the uh, precipitation process, when it is changing, it is having implication on the uh, flow or runoff water during a monsoon or post monsoon and pre monsoon season. So that is how it is going to impact the agricultural process or livelihood, even ecosystems as well in different elevations. We have started from the glacial modeling to the hydrological modeling, and then flooding in high mountain, mid mountain, or mid hills, and also plains. So we have seen each region have its own challenges due to changes in monsoon. Thank you.
Okay. Well, thank you for laying that foundation about how the monsoon works, what's anticipated to change. And I think maybe now that we understand how climate change is destabilizing the monsoon, Doug, could you please explain to us what stratospheric aerosol injection actually is, how it's researched, and why some researchers are exploring it as a possible climate intervention given we are within the bigger picture of climate change?
Sure. So to start with, of course, we need to be cutting our greenhouse gas emissions, principally carbon dioxide. If we had started doing that aggressively 30 years ago, maybe we'd be in a slightly better position now. But we are, roughly at 1.5 degrees Celsius warming. We probably not even clear whether we've peaked in our emissions globally. So we are nowhere close to on track to meet any of the targets from the Paris Agreement. I was at an event that I was at a week ago. Somebody said that her guess was that we were headed more for like 3 degrees Celsius warming. And then, of course, there's uncertainty on top of all of that, not just in policy decisions, but how much the Earth warms. So then the question is, what do you do about that? Obviously, you can be more aggressive in cutting emissions, but the planet's going to keep warming. So the idea of reflecting sunlight away is, what do you do in the interim to more quickly manage climate change damages? If you reflect sunlight, that cools the planet. Multiple ideas on how you would do that, but the one that's by far the best understood and could probably be done the most quick, the soonest, would be you put aerosols into the stratosphere. So small droplets, high enough in the atmosphere that they're relatively stable for a little while. We know it works because volcanic eruptions do this every now and then and cool the planet. Uh, so basically, you fly airplanes filled with sulfur dioxide or something like that up into the stratosphere, you release them, they stay there for a quarter of a year, and that reflects sunlight and cools the planet. In terms of overall risk trade-offs, of course, that cools the planet, and lots of climate impacts are driven by temperature, certainly heat extremes and things like that, melting of ice. But if you warm the planet by adding greenhouse gases and then you cool it back down by reflecting sunlight, you don't get back to where you started. And that's particularly true when you start talking about precipitation systems. So that's sort of broadly the avenue of research, is to try to do a better job of understanding, if people were to choose to deploy this in the future, what would the effects be? How do those depend on things that we can choose, like where to put the aerosols in the stratosphere? How confident are we? And how do we reduce some of the uncertainties? And so that people can make reasonably informed decisions in a reasonable time frame. There's sort of a physics part of that, what would happen to the climate system? And I'll leave aside the whole bigger question, which is, how would people actually decide, is a thorny question.
Yeah, that was the quickest SAI 101 I've ever heard. Thank you.
Oh, I can
Record
spend 2 hours
breaking.
talking about it if you want, but trying to give you like
Um,
the thumbnail top end strategy summary.
No, I think I need to speak faster when I speak about it. But would you be able to maybe walk us through it in a bit more of a, or in smaller steps, or paint a clearer picture about what a potential SAI program, if it were ever to be designed, what it might look like, how it could look like in practice, and how it would be done. Of course, you explained the natural analog with the volcano and the aeroplanes, but could you maybe just walk us through it a little bit more slowly?
So I'm going to actually back up a little bit in terms of, the idea is not new. And 25 years ago now, Bala and Ken Caldera did simulations where they just turned the sun down. The idea actually was, hey, you can't possibly manage climate change by reflecting sunlight. And more or less what they found is, hey, it works reasonably well. The research gradually shifted to saying, we've got climate models that simulate what happens when a volcano goes off. So let's try those. And the broad answer at 20,000, if you take a step back, the broad answer is, it actually does seem to work reasonably well, provided that you do things in a reasonable way, which is to say, you want to make sure that you put equal amounts in each hemisphere, roughly, so that you're not shifting the tropical precipitation too much. So that's sort of where the research is. We've been doing lots of climate modeling. The climate modeling overall is certainly far from complete. If you were, and there's clearly more that needs to be done, but given that it looks like it has a strong potential to reduce impacts, accelerating that research would make sense. That might, in addition to the modeling, bring things in like fly an airplane to the stratosphere, release material that would resolve some of the uncertainties in aerosol processes. If society then decided to keep going, you would start small, flying airplanes to the stratosphere, release material, observe exactly what's going on, and gradually ramp up. If you ask me, I would say the absolute earliest you could imagine such a thing happening from a purely technical perspective is maybe 10 years from now. And then over the next decade, the fastest you would want to ramp up, you might be at about a half a degree of cooling. And that will be relevant, in talking through things like the effects on the monsoon. Um, you will clearly see reductions in temperature on that sort of a time scale. The signal to noise, because of the variability, it may be very difficult to figure out exactly what is happening on the monsoon in that sort of a time scale.
As you've just said that this is what a program might look like, and large scale deployment is not something that's happening now, and it won't be for at least the next decade. So could you please just briefly explain to the audience how SAI is researched? How do we understand what it might mean?
So right now we're researching it in climate models. Same models you use for climate change, same models you use for predicting the response of volcanic eruptions. They're never perfect. They don't all agree. The response depends on the scenario you choose. It depends on where you put aerosols in the stratosphere. And so it becomes a little bit more complicated question than just saying what happens under climate change, because in this case, we actually get to choose where to put things in. And then, as I said, I don't know how decisions will ultimately get made. That's a hard question. But I would hope that more scientific knowledge is helpful to that. And eventually, what we need to be doing is trading off the risks of climate change against the risks of deployment. And those risks of deploying include not just here's the physical effects of well-managed, broadly responsible deployment, but also things like if you started deploying and people chose to stop at some point, you get what's called a termination shock. Temperatures rebound. There are concerns out there. I don't personally share them, but there are certainly strong concerns out there that this would lead to less mitigation. People would say, oh, great, we've got a solution. We don't need to cut carbon emissions. And there's a concern over conflict, right? So suppose you were to deploy, and even if the model said this would help things with the monsoon, but supposing the next year you have a particularly bad strong monsoon or a particularly weak monsoon, now suddenly that gets blamed on the deployment. And so how do you manage that? So I think, it's not how do you manage those governance issues are also a very important subject of research. But broadly, it's climate modeling and then, in principle, small scale experimentation to validate uncertainties in the model, and then making sure we take the output of those climate models and make sure that everybody on the planet has access to those simulations and can look at the responses in their region, right? Like I can run climate model simulations, but I'm far from the expert on what actually matters to local farmers in Bangladesh. That type of research shouldn't be done by somebody who looks like me sitting in the United States.
Oh, of course not. That's very practical. Thank you so much, Doug. I think this was very helpful to ground us in what SAI is and the kinds of trade-offs it might bring. I want to turn now to Professor Bala. Your work looks specifically at understanding how the South Asian monsoon could respond to SAI deployment. So to begin, could you please walk us through, in simple terms, why the South Asian monsoon in particular is so sensitive to this kind of intervention?
Yeah, thank you, Lisa. Yeah, let me actually, I just don't want to hype it up. There is a lot of hype and so much noise generally about climate change as well as about solar geoengineering. So I think you said your question, why it is so sensitive. In fact, I would say the opposite, actually. I mean, if you look at the last 150 years of, let's say, monsoon rainfall record, um, I mean, we know monsoon is a pretty stable system, particularly the South Asian monsoon system. Like a clockwork, it arrives in June and it retreats in September. Okay, so like a 4 month period. But I think what is really, uh, really that affects people in India and South Asia is basically the year-to-year variability in monsoon rainfall. So, for example, the all India rainfall um, the interannual variability, the standard deviation is about 10%. So some years, for example, some years it could be 20% excess or 20% below normal. So these are the years which are really, I think, in some sense dangerous. It could have devastating influence on people. Um, so the interannual variability is a very important thing for monsoon. I mean, let's be, put a on top of that, now we have, greenhouse gases, aerosols, and deforestation. They could actually, of course, change the climatological mean rainfall or the variability. Okay, so this is where I think we need to, I mean, of course, there are a lot of papers that look at that. So this could have a lot of influence, and so one should be aware about that. And I think the big sensitivity is really it comes from the that mostly socioeconomics. If you look at the entire tropical monsoon area, nearly I think 3/4 of the global population actually live in the tropical monsoon regions. And if you think about South Asian, nearly a quarter of the global population lives in South Asia. So here, agriculture is, in fact, if you look at India, I mean, I know the numbers for India. the GDP is contributed by agriculture by about 15%. But if you look at the employment, nearly 50% of the people are employed in the agriculture sector. So, this is where monsoon actually becomes extremely important, and any disruption, whether caused by climate change or stratospheric solar geoengineering, actually could have, disastrous effect on the people and also, maybe the economy. There is a lot of uncertainty, but I think this is where we need to work on to reduce the uncertainty. Yeah.
Oh no, thanks for laying that out for us. I just want to dig a little bit more into the nitty-gritties if we can. So we understand and that your work has looked at the mechanisms, so things like shift in the rain belt or weakening of the hydrological cycle. Could you please help us understand how aerosols in the stratosphere could change monsoon rainfall?
Yeah, my work, of course, I've been mostly looking at, the climatological annual mean rainfall kind of thing, not really the extremes. Um, as far as my understanding is concerned, I can list actually three key, large scale energetic mechanisms that could actually, that govern the monsoon rainfall changes. And one is, just putting, let's say, aerosol into the stratosphere, right? See, the rainfall sensitivity to greenhouse gases and sulfate aerosols, they are actually different. So if you exactly, let's say, offset global mean warming, you actually end up reducing the global mean precipitation. So this gives you an idea. So you don't really need to offset the entire global warming.
Actually, I like fruit except.
There is somebody else speaking. Okay, so the second one is we basically looked at how interhemispheric differences in aerosol loading could affect the position of ITCC, and monsoon. So the current wisdom is that monsoon is really intimately tied to the seasonal migration of the ITCC in the tropics. So as we know, monsoon, the ITCC always moves into the warmer hemisphere, right? For example, we have monsoon in India in June, July, August because, yeah, that's the summertime, right? So if you actually, by doing aerosol geoengineering, if you actually warm I mean, if you cool one hemisphere more than the other hemisphere, what's going to happen is the ITCZ is going to move into the warmer hemisphere. So this is more like a disruption. And I think the other third one I am really, we have been in my group looking at is basically the effect of stratospheric heating. I mean, all of us know, we inject aerosols because aerosol produce cooling, right? But these aerosols also have a little bit, heating effect. So they do actually heat the stratosphere. So this actually for monsoon system, this could actually have, I mean, some somewhat strong influence if you put the aerosol, let's say, very close to the tropopause. So these are, three mechanisms. Basically, we have been looking at the global amount of aerosols, how it would affect, and the interhemispheric, asymmetry between the aerosol loading and also the altitude of aerosol, because the stratospheric heating really kind of depends on the altitude where you put the aerosol. So that these are the three mechanisms that, I mean, at least as far as I'm concerned, now I'm aware of. There could be more, but these are the three mechanisms which I think could have very strong control on how stratospheric aerosol would impact not only South Asian monsoon, in fact, the entire tropical monsoon regions. Yeah.
Okay. No, thank you for explaining. I mean, you are the expert, and so I want to ask you that when you look across modeling studies or modeling studies that you've done specifically to you, what are the signals that stand out that are related to the monsoon?
Oh, okay. In fact, most of my studies, we have been looking at broader tropics, but only recently we actually started looking at specifically the South Asian monsoon. And so in this particular scenario, what we find is under climate change, of course, the rainfall over India on an average increases, but we find actually the annual mean rainfall over India actually decreases by almost 10% when you do solar geoengineering. So we are basically looking at this, and what we are finding is that in general the circulation is basically monsoon is basically driven by southwestward winds, right, in the low levels. So what we are finding is actually the circulations are actually weakened under climate change, and the weakening is, in fact, even you find actually larger weakening under solar, this is stratospheric aerosol geoengineering. And we are actually right now looking at the reasons for it. One of that could be actually the stratospheric heating, right? I mean, because this heating in the stratosphere actually a little bit produces stability. But anyway, in a nutshell, what we are finding is the monsoon circulation is weakened by stratospheric aerosol geoengineering. And other studies have also, kind of noticed this. But right now, we are basically digging deeper into this, and we are looking at many more dynamical circulation indices. And in all cases, we find that under climate change, there is a weakening of circulation, and it is larger under stratospheric aerosol geoengineering. Yeah.
Thank you so much, Professor Bala. I think this gives us a very useful picture of what might be at stake for South Asia, and I imagine you'll go into depth a bit more when you do your presentation. So just to recap, we have now heard about how climate change is already stressing the monsoon, what SAI is and why it's being studied, and how it could shape rainfall in the region. So with this foundation in place, I think it's time we move on to our next segment, where each of our panelists will take us a bit deeper into their research, bringing in more detail and evidence on these themes. And I will ask Doug to kickstart the presentations about SAI. Thank you.
Let me start by unmuting and going into slide share mode. And sharing my screen, just a sec. So I'm just going to provide a few graphics that support or that relevant to the things that I already said. So first is just to show you, this is sort of broadly the argument for considering things. This is from one climate model with one scenario with one strategy. The top left picture is just the pattern of warming you see from climate change. This is for a particular scenario, but it's scaled to 1 degree Celsius. And the bottom panel below that is the warming pattern. If you then, add that greenhouse gases, you warm the planet by a degree and you cool it back down by stratospheric aerosol injection. And everything that's hashed is not statistically significant with, I believe this is with 3 climate ensembles of the simulation. And broadly speaking, what you see is it does a pretty good job on temperature. And then if you look on the right-hand side, that's the rainfall patterns. It doesn't do quite as good job. This is annual mean. So take that with a big grain of salt, right? This does not capture changes in the statistics. It doesn't capture changes in, variability. It doesn't capture changes in timing. But again, if you looked at those 2 plots, you'd say mostly in most places, the changes in rainfall aren't particularly statistically significant in this particular simulation. I'm just going to show you one other plot here as well. If you want to go play with this yourself, Reflective, which I'm a part of, nonprofit that I started, produced a beautiful simulator tool. This is the PowerPoint, so I can't just show it, just a screenshot. I can't show you in real time, but if you go to their website, you can go play with that. There's a slider bar to move back and forth to visualize things. It does not have all of the variables in it that you might be interested in, but you can play with scenarios and get a sense of what at least this climate model shows. We are talking about the monsoon, so I'll just show you as well what happens to the annual mean rainfall. Again, this is annual mean. It's not variability or seasonal timing or anything. But the top plot here, this is just from one of my grad students who's actually on the call, Harsh. This is taking an area in up against the Himalayas and just looking at the temperature in that area, historical trend, and then gradually increasing over climate change. And if you were deploying some amount of stratospheric aerosols, the temperature you could basically choose how much you inject. And so you can more or less choose whatever temperature you want. And then the bottom plot is the corresponding annual mean precipitation in the same region. And more or less what you see is in this climate model, in this scenario, in this strategy, there's no change in the annual mean precip. And those 3 caveats are actually pretty critical because it doesn't say anything about what might happen in some other climate model, some other scenario, or with a different strategy, as Bala already alluded to. Just taking, I think I said this, but just to take a step back, and Bala basically said this as well, why is research in SAI, or for that matter, we didn't talk about marine cloud brightening in this call. We could broadly make some similar things with statements about marine cloud brightening. Right, when you study climate change, you put CO2 into the climate model and you see what happens. And as soon as you are studying SAI, not only do you get to choose where you put the aerosols in principle, and how much to put in, but you can also in principle revisit that choice every year. With CO2, the lifetime is very long. If I put a ton of CO2 in, it stays, most of it will still be there when my grandchildren have passed away. If you put sulfate into the stratosphere, the lifetime is of order a year. That both means you have to constantly add more sulfate to the stratosphere, but it also means that you always have an opportunity to look at what's happening and adjust your strategy. And as I've said, in some cases, that means nobody is going to be sitting there in 2100 saying, Doug McMartin, before he died, said we should be putting in 15 tons this year. So that's what we're going to do, right? You're going to observe what happens and you're going to use that information. And that's absolutely critical for thinking about uncertainty as well. Some of this also makes the governance questions more challenging as well, right? Because they really bring into question who is making decisions and for whom are those decisions being made. Just to, we've done simulations with injecting at lots of different latitudes and also even with the timing of injection. For the most part, the timing of injection matters throughout the year matters mostly for high latitude, although specifically for the Indian monsoon, you can, for example, alter the timing of when you put the aerosols in so that if you put the northern hemisphere aerosols, you can allow a slightly lower amount of aerosols in the spring and summer. That will cause Tibet to warm up just a little bit more. That will strengthen monsoon circulation, right? So there's lots of knobs that can, in principle, be turned here. I basically said all of this. Maybe I'll skip this slide because I think I said that in practice, but in my introductory comments. If you go back to, say, I put this plot up and said, in this model, you don't see much of a change in the annual mean. If somebody else says, but in my climate model, I do see a change in the annual mean, absolutely. There's uncertainty. And in fact, it might be that all of the models are wrong. So how do we think about that? First of all, is to be clear about there have been historical changes. If you bring temperatures back down to, say, 2030 levels, are you overcompensating changes in the monsoon, undercompensating changes, or as Bala said on some of the circulation issues, are there cases where climate change makes something worse and then stratospheric aerosols might make it worse still? In some cases, I've seen people take simulations where they do 4 degrees of cooling and 20 ensemble members, and they look at 400 years of simulation with 24 degrees Celsius of cooling, and they say, aha, I can detect a change, but that doesn't mean we care in the real world. We do have some fairly strong influence on the monsoon precipitation in principle, by choosing whether to put a little bit more injection in the northern hemisphere versus a little more in the southern hemisphere. And so in principle, you could say, the stratospheric heating from the aerosols is causing monsoon strength to go down. I'm going to compensate for that by putting more aerosols into one hemisphere versus the other in order to increase the monsoon precipitation. That's a knob that could be turned, but of course, there's an entire planet to worry about. And when you turn that knob, that may also change trade-offs in other places. And so all of these things need to be evaluated more carefully. And then the reason to emphasize the ability to modify to constantly revisit decisions, if you were ever launching a deployment, the very first thing you would do, and I actually think we should probably be trying to do this as soon as we can, would be you fly one airplane, you measure the aerosol microphysics, you understand how big the aerosols get. That is, the size of the aerosols has a big influence on the amount of stratospheric heating, for example, which, as Bala said, in turn affects the monsoon. You would then say, all right, I'm going to put in 100 kilotons of sulfur dioxide, hypothetically. That doesn't affect the climate, but it will resolve all of your uncertainty in where the aerosols go from a given injection choice. So those types of uncertainties get resolved before you've even started anything that looks like affecting the climate system. And then you can start ramping things up and say you're at a 0.5 degree cooling, which, by the way, is plenty to offset lots of climate impacts. And you decide, I'm not quite happy with what this is doing to the Indian monsoon. At that point, you have the option to change your strategy. You have the option to ramp back out and so forth. So these are sort of critical in thinking through the uncertainty piece. I haven't been watching time. I'm not sure how I'm doing.
Sorry, Doug, you have reached your 10, you've maxed out, but if you would like to wrap up over a couple more minutes, that's really all right. Go for it.
Let me actually just give you one more slide, and I would say don't look at the details of where anything on this slide is right now. They were just sort of this was like literally putting on a whiteboard in 10 minutes with some people in the room. So much as conceptually, one of the things we need to do with regards to uncertainty is isolate. These are all of the things that we don't know. How wrong might we be about them? How consequential would they be? And write down a plan for how we might resolve them. So through Reflective, we've actually taken a stab at this. I think an email went out to the Geoengineering Google group about a week or so ago and to a number of other people. So if you're interested in giving us feedback on that attempted uncertainty database for all of its flaws, we basically figured we'll start getting feedback now. We would certainly welcome that input as well. And I will stop there.
No, thank you so much, Doug. That was a lovely, it was nice to see some graphics which can help make things feel a lot less abstract in the mind. So thanks for laying that out for us, so the fundamentals of SAI a bit more. I'm going to hand over to Bala. Maybe you can show us a bit more about your research and into SAI. Thank you.
Sure. Can I share my slides now? Okay. Yeah, can you all, okay, let me do that.
Yeah, we can see your slides.
Okay. Yeah, okay. So I think I'm just going to elaborate on a little bit on the monsoon and climate change and the basic mechanisms by which, the monsoon could be affected. Okay. Yeah, so just for, this is a graphics I took from this Global Tipping Point Report 2023. So the actually 6 monsoon regions are indicated in this. I think one thing I wanted to notice is look at the Indian summer monsoon. It is way up north, right, compared to the other monsoon regions, right? So it just basically the ITCC really moves too much north into the South Asian region during the monsoon season. And I'll quickly go through it. So this is a kind of a summary slide from the previous IPCC report 2013. So what you can see is no matter whether it is a low warming, low emission scenario or high emission scenario, the monsoon rainfall, the mean climatological monsoon rainfall increases over South Asia by 2100. And I think what is concerning is this change in the extremes. So I'm just not, I don't, you don't have to look at the details of this slide, but I think the main conclusion is that interannual variability and extremes in precipitation and duration of the monsoon season are projected to increase. Actually, even 10 years back, this report shows that actually monsoon onset will be earlier with climate change and the retreat will be delayed. So the total duration of the monsoon will increase. And also the main thing again you can note is the extremes actually increase under climate change. Now, I think many are actually concerned about whether monsoon system can undergo abrupt changes. So I think those who are interested, you can go and look at this report, Global Tipping Point Report 2023. So the conclusion is that, yeah, only the North African monsoon, there is evidence that it has undergone abrupt changes. But as far as the Indian summer monsoon is concerned, it's a very stable system, at least in the centennial timescale. Only thing is what is really bothering many of us in India is the year-to-year variability. So according to this report, South Asian monsoon is not a tipping element, but it is a nonlinear system. Okay. Um, so I think I just a little bit go back. The first alarm about how the stratospheric solar geoengineering could affect the Indian monsoon was basically by this paper from Alan Roebuck in 2008. So I just to read this out. Both tropical and Arctic SO2 injection would disrupt the Asian and African monsoon, reducing precipitation to the food supply for billions of people. But I think, honestly, at that time, the mechanism were not very clear. This was a result from a model, and it showed reductions. You can see that gray color in the tropical region. And also, this is from a very coarse resolution model. Now, I think we understand a lot better now about monsoon response to climate change and solar geoengineering. So I think I'm going to only this will be my last slide. So I'm just going to elaborate on the three mechanisms that I highlighted earlier. So the first one is the interhemispheric difference in aerosol loading. This could actually disturb the latitudinal position of the ITCC monsoon. So like in the seasonal cycle, ITCC would move into the warmer hemisphere. So what's the solution for this? So basically, you got to make sure, I think Doug and others have produced lots and lots of papers where they actually take care of this by injecting aerosols at multiple latitudes. All right. So the second one is I actually talked about the precipitation sensitivity is different for greenhouse gases and sulfide aerosols. So I think so because of that, if you offset the global mean warming, the whole global as well as tropical hydrological cycle will be weakened. But you can take care of this by not really fully offsetting the global surface temperature change. Instead, you could actually, let's say, target for a 1 degree cooling or half a degree cooling. So you don't have to really go back all the way to pre-industrial. So that will take care of this particular, constraint from stratospheric aerosol geoengineering. And the third one I indicated was this stratospheric heating. It is actually for lower altitude, SAG, that is stratospheric aerosol geoengineering. And actually, this reduces in fact, in an addition, it reduces the cooling efficacy. So if you have more stratospheric heating, you are going to actually reduce the cooling effect that you are targeting. But interestingly, our recent study showed that for a fixed amount of aerosol, the precipitation shows very little sensitivity to the height of the aerosol layer. Okay, but obviously there will be less cooling if you put it at the lower altitudes. And the secondary result from that is for the same amount of cooling produced by stratospheric aerosol geoengineering, global and tropical mean precipitation are reduced more for aerosol at lower altitudes. So, clearly it shows, don't put aerosols, closer to the tropopause, just above lower altitudes in the stratosphere. So what would be the solution? So we have to, I've been thinking about this. So I think the best solution is, you come up with a design. Come up with basically this can be controlled by the type and size of the aerosol particles. So ideally, what I would really like is, how you can achieve large cooling efficacy by careful choice of the aerosol as well as size of that. So you reduce this heating and it's not a big problem. But of course, you have to also worry about the toxicity of the type of aerosol. So I think these are the should I stop now? Because I do have more slides, but
no, there's still 5 minutes or so for your presentation, so please carry on.
Fantastic. So let me quickly illustrate this same mechanisms. All right. So mechanism one, change in interhemispheric difference in aerosol loading. So I have a nice schematic that shows that. In this particular schematic, this is only schematic, right? Most of the aerosols are, reflective aerosols, let's say, are there in the northern hemisphere. So this schematic shows how the ITCC could be pushed to the south, and basically then, the northern hemisphere monsoon regions will actually receive less rainfall. So this is actually, there is fundamental science associated with that. So I have written that here as planetary energetics. So basically ITCC moves into the warmer hemisphere. So it doesn't matter whether it is a seasonal time scale or something that is created by climate change or climate intervention. So this is a fundamental mechanism that operates. And yeah, so there is evidence for this. Actually, here is a statement from the IPCC, recent IPCC report. Actually, in this report, they actually look at the effect of only aerosol emissions in the historical period. So this shows very clearly, actually, because of aerosol emissions only in the northern hemisphere has actually cools more than the southern hemisphere due to only aerosols. So because of this, as I said, you could actually reduce the decrease in monsoon, northern hemisphere monsoon rainfall. Okay, so now mechanism two. So I just want to show this just from just one illustration. So the top two panels, they show the temperature change. The left panel is for, when you double the atmospheric CO2 concentration. And the right one is basically when you offset that, basically when you inject, I mean, in this case, we prescribe aerosol. So you can see that nicely, the global mean temperature change is basically exactly offset. But you look at the bottom panels, again, left panel corresponds to doubling of atmospheric CO2 concentration, and the right one shows the precipitation change in the uh, stratospheric intervention case. So you can see that in climate change, there is nearly 6% increase in global mean precipitation. But you can see on the left, the global hydrological cycle is weakened because you can see there is a 2.3% reduction in global mean precipitation. So yeah, you don't need to exactly offset the warming. So the final one, I mean, this is from a paper, but I really don't want to show too many things in this. So um, I just want to show only the result for India. Um, so what you see here is, we basically prescribed aerosols, the same amount of aerosols at three different heights, 16, 18, and 22 kilometer. And what we found was there was really very little sensitivity to the altitude of the aerosol layer. But remember, the cooling efficacy, of course, is reduced when you put the aerosols at lower altitudes in the stratosphere. Okay. So this is same as what I had before. So it gives solution to all these three mechanisms. The first one, you have to have hemispheric symmetry in aerosol loading. The second one, you don't have to really offset the full warming since pre-industrial time. And third one, I think, the stratospheric heating could be reduced by right choice of the type and size of aerosol particles. And I think, I just have one slide on really the massive uncertainty in the aerosol problem. So, for example, this is from a paper in Journal of Climate last year. It shows actually the aerosol evolution is extremely important. For example, the leftmost panel shows basically the Mount Pinatubo eruption case where the aerosols actually produced cooling. So there are two cases on the right. You see, in one case, the aerosols are mostly distributed among very fine particles, and on the other case, you have aerosols. Basically, the mass of the aerosol material is distributed among fewer but larger particles. So in the later case, you have heating, and in the case where aerosol, you produce fine aerosols, you actually produce large cooling. So there is a lot of uncertainty, so basically in this aerosol evolution stuff. All right. Anyway, so yeah, this is just, where the research should be, at least with relevance to tropical monsoon precipitation. So, more work. Yeah, I think I don't have to read this out. And this is I believe my final slide. Yeah.
Thank you so much, Bala. Thank
Yeah.
you. That was
Okay.
lovely. For
Yeah.
the sake of time, I'm just going to hand over active immediately to Abu for your presentation.
I'm sharing my screen. Okay. Can you see it?
Yes, we can see.
Yeah. So it's already, as Bala also emphasized, then the global population, also South Asian population, who are really dependent on the South Asian or uh, Indian monsoon here. So you can see the different number of population living in different basins here. So, and the number of hot nights or hot days, there are changes what is projected in one of our work here. And these are all published work, my own work with other colleagues. So this is what we have seen the changes in different cities in South Asia. A number of hot nights, how it is changing or increasing in different in climate change scenarios. So the geographical coverage of uh, hot areas are going to increase in different scenarios. So that is how it's, and what Bala was also saying that the what I want to mention it as a teleconnection between northern hemisphere and southern hemisphere. The process, uh, whatever we have in southern and ITCZ, uh, any changes in the process, whether it is there is a huge uncertainty how it is going to influence the ITCZ and also the process in South Asian region. So what we see when for a warming uh, scenarios, what we saw at RCP 4.5 and 8.5, the river basin is experiencing reduced amount of water. So magnitude may be doubled due to the increased melting of uh, glacier, and also again you have a effect of like a certain period like around 2047 to 2060s, there will be a high uh, flow in the river from the glacial melt, and then afterwards you get dry. So when you have a change in the monsoon, as Bala was also mentioning, that there is a change in the monsoon rainfall, the extension of rainfall or changing in onset. And I have found it in published in 2011 or 2012 in where we have seen that monsoon onset is changing almost like 15 days, and it was corroborated by the perception survey even with the communities throughout Bangladesh, in all the regions of Bangladesh, where we have done the physical modeling as well. So that was confirmed by the perception surveys also, and the and contribution of total flow by glacier melt and snow melt and rainfall, so that you can see in many rivers you have the contribution of rainfall amount is very high, whereas you have a bit less in some of the basin. When you have a high rainfall contribution in a basic flow of the basin or river, and if there is any change, the all taking all the uncertainties, and then we will have a challenge in the people's life and livelihood. So if we take the different elevation at different elevation, we can see the changes. So I'm not going to detail on that one. And this is the one what we have been experimenting with the SAI in different basins around Bangladesh. So we are trying to do it Ganges and Brahmaputra and Magna basin. So Magna is the smallest basin here. And what we saw here also, there is a change in post monsoon flow and monsoon flow as well. So you can see it here. You can see the black line. That is the one with the models scenario SAI. It is changing a bit at one in June, particularly only in June, it is increasing, but later on and before it is decreasing. And if you go to this one, the mean yearly discharge at Bhairav Bazar, this is a particular discharge point we have taken into account and the hydrological measurement we have, observation data. And here you see there will be the blue line is showing that there is a decreased flow in the river in SAI scenario. And so G6 sulfur scenario. So we can see that there is a decreased flow of the river. And this decreased flow of the river, and continually it is going higher and higher. So there is a decreased in flow means there will be change in monsoon as well. So and this elaborating in a in different way, the basin maps, and the how it is impact in people's lives and livelihood. If I go to the same particular Brahmaputra region or Tista River basin or sub basin, you can see this is the flooding season. So the people are floating even now. This is flooding now. During last week, there had been a lot of water coming from upstream. So we are always in the recipient end. We are in the floodplain at the bottom of the Himalayan mountain system. So the water is coming from like upstream, like China, India, Nepal, and then it is flowing to the Bay of Bengal, and we are just taking the water to the Bay of Bengal, and with the sediments. So the can you imagine this same point of this river is having this due to the sedimentation of the river, and this is the dry season of the same point, same area. This is the dry season of the same river where you have this flood. And then there are people are growing like corn or maize. And then, so if we take the example of how this is changing the river flow, you can see the river course is changing. You see, from 89, it was where, and in 2000, in 2010 and 2016, the river flow has been changed. So this clearly displays the people. So any change in hydrological process or in monsoon going to impact the people in the river basin, and how it is impacting, that is one of the manifestation here. I have shown it, and I can give you another example. Like here, if you zoom in, you can see the changes. In particular, this one, you see how the river flow is changing. So in every 10 years, it is changing. So the people are really displaced due to these changes in the river flow. And if I take the example of a particular person, we followed him from 2001 to 2016 and onwards. So this guy in 2001, he was in here. I'm not sure whether you can see the point at 2001, where this red line starts from. His house was over there. And then in 2003, he had to move because of the erosion and the changes in the river flow. So he had to move to the next point in 2003. Again, it was eroded, and he had to move to 2005 in another location. So he's changing his home. And again, that was eroded. In 2006, he had to move. He moved again 2007. and 2009, moved again 2012, and 2014, 15, 2016. So, very interesting point. I don't know whether you have noticed it. You see, this guy is changing his home, but he's not leaving that particular area. He made a complete circle of that area, but still he didn't leave it, that place. And this 2016, through one of our research project, we gave him a house around here in 2016 so that he moved to a mainland, which is less susceptible to erosion. So, if there is any change in hydrology or in monsoon water flow, there will be more erosion or more impacts on the people's lives and livelihood. And this is one of the demonstration what we can see. And that is where we have given some, these are the some consultation we have done, and we have done this flood resilient housing options for the people there. That's all from my side. Thank you.
Thank you so much. It's actually so wonderful to end on a positive note. And you know, I want to thank all of our panelists for these excellent presentations that built on our earlier discussions so nicely. And I imagine there are some more questions to talk through now. So I want to open the floor to some Q&A. And Doug and Bala have answered some questions already in the Q&A chat. So I'll just direct some of the ones that haven't yet been answered. And we'll start with Abu. There's a question for you from the beginning, asking which kinds of crops are affected because of the change in monsoon season. Which are the primary crops affected by changes in monsoon?
Mostly rice is the major crop during that period, but during now, the late floods usually affect the potato and other crops like vegetables. Mainly rice, one is the major crop. This is the only staple crop here in Bangladesh. And then you have maize, onion, and all these things. But the late floods usually affect the other crops. The main affected crop is rice.
Okay, thank you. Sorry, were you done? There's one question, Doug, I think you missed maybe. It says Bill McKibben feels very confident that renewable wind and solar will power the world economies in 30 to 40 years. But if it takes 30 to 40 years, the wind and solar will be powering a broken planet. He understands the urgency to draw down and sequester legacy carbon, but lack faith that carbon dioxide removal of any sort can be made economically and effectively viable. The conundrum is clear. McKibben, Mann, and a couple of other leaders refuse to allow SRM and SAI research. Thoughts on how to bring them on board?
I mean, I think broadly, of course, anybody who says that we have absolute 100% confidence that future mitigation will, combined with future CDR, will be sufficient to avoid future climate damages, does not understand climate change, or does not understand technology, or is being disingenuous. My guess is that, so personally, I would say virtually every single person I talk to is supportive of research. I think it's a very, very small minority of people that are opposed to research at this point. And the people that are opposed to research, I think, tend to fall into two related camps. One is that they're absolutely convinced that this will lead to less mitigation. And second, there are people who would say, You cannot deploy SAI in a just way. You can't make decisions about it in a just way. Therefore, we shouldn't do it. I don't personally find either of those arguments compelling, but those are the arguments that are made. Some of those people will follow Michael Mann's lead. I'd say personally, I wouldn't waste my time trying to get Michael Mann's opinion changed. My reaction is just to go ahead and do the research.
Thank you. Greg asks a question. Greg says, I presume in a real test program, it would be many such flights, not one, and it would be a learning process to get the data needed. Trying to dry lab a single experiment first with modeling is unfeasible and could delay the single plane load test indefinitely.
Yes, it would be more than one flight. You need to test all sorts of different things. In it, you can't guarantee any specific flight would be successful. I'd say we are working trying to figure out exactly what experiment you need to conduct, like how much material do you need to release, exactly what uncertainties are you trying to resolve, and how do you design the whole thing. And I think it's actually very interesting, even thinking about, oh wait, how would you go design an experiment to validate aerosol microphysics? The issue essentially being how things get released in a volcanic eruption that we currently use to calibrate models is not the same as what happens when they come, out of some nozzle at the back of an airplane. But just thinking about how to actually do that experiment raises so many questions. There's like, we've been for 25 years thinking about SAI in sort of this abstract artifact of modeling, and we have not been answering all of the questions about, okay, how would you actually go do this in practice? So that's sort of, yes, I happen to think that an experiment of this sort would be a valuable thing to help resolve some uncertainties. But as a more general thing, it's sort of a call for saying, let's make sure we take this idea seriously and evaluate it. I'd say we will do, if it was purely up to me, I'd say we'll do that experiment as fast as we can. I think it's going to take 5 years.
Okay. Thank you. Do you know what? Since Bala and Doug have been answering questions as they've been coming, I think we can actually call it for the Q&A session. And I want to thank you to our audience for engaging, and thank you to our panelists for answering their questions so thoughtfully. And now
Excuse me, madam.
Oh, sorry.
May I just interrupt, actually?
Sure.
May I just raise a fundamental apprehension regarding SAI or SAG? My fundamental apprehension that although we know that these days this alternative energy and non-conventional source of energy is 15% cheaper than the fossil fuel one. Even then, a lot of thought process and the brilliant people are being engaged in SRM or SAI, all knowing fully well that SAI may encompass this ozone depletion, the acid raining, and of course the blockage of the sunlight. We do not know how sunlight doesn't only affect the cooling, because the entire our biological system depends on the sunlight. So the 53% of our body is basically not really our own. Other thing that these are sensitive to the sunlight. So any changes that mimicking the nature, what kind of disaster certificate can we simply do not have the idea. We have got a very little knowledge.
First of all, we're not in a position to even make a decision on whether or not to deploy. The question on the table is essentially how much research to do. When it does come for that decision to deploy, I agree 100% with you that we need to take seriously all of the pros and cons, all of the things we know and all of the uncertainties. And of course, we're in a world where not deploying also comes with huge, huge risks and huge, huge unknowns. The specific things that you actually mentioned, yes, people are aware. Yes, people are researching those. The effects on ozone are actually pretty small in the grand scheme of things. That's not going to be the issue. Same with acid rain. Same with photosynthesis. We're not talking about big reductions in sunlight. We're talking about, fractions of a percent reduction in sunlight. But yes, absolutely, I agree. We need to do a better job of understanding all of the downstream impacts and risks and doing some sort of a trade-off and careful assessment of the consequences relative to climate change.
Thanks, Doug. I think I just want to keep my eye on the clock. Would our panelists like to share one key takeaway or reflection, just 1 minute? If you feel like you've said everything you'd like to, that's also all right.
I think I just did.
Thanks, Doug. Bala and Abu, the floor is yours if you'd like to say any last bits.
Yeah.
I want to also emphasize on the research should go ahead, I think. So we have to understand the last questioner and his concern also. To understand his concern, to respond to his concern, we need to do the research. Thank you.
Bala, you're off.
Yeah, I think, this is a point I just, in a broader sense, I've been doing SAI related scientific research. I have very little really expertise in socio-economic or political aspects of even climate change and this climate intervention. But my thoughts are basically, I'll just read out what I wrote here. I consider SAI as one component of broad portfolio of climate change risk management. As many of us have already expressed, the focus should always remain on mitigation and adaptation. But I think there is always a tiny probability. Suppose that does not happen in this century. What if there is a real planetary emergency that can be unambiguously attributed to global warming? I must, admit, of course, whether we will ever even have a global consensus on the definition of planetary emergency, that also it's not clear. So if there is a planetary emergency, so what is the option that can cool the planet in a relatively very, very short time, let's say 1 to 2 years? It's only SAI. There is no other option if there is ever a planetary emergency. So for this reason, my feeling is, there should be some resources that should be used to do research in solar geoengineering. Yeah.
Okay, wonderful. Thank you so much, Doug, Bala, Abu, for sharing your expertise and perspectives. And on behalf of HCI, thank you all for being part of the session, and we look forward to continuing the dialogue. Okay, thank you, everybody.
Thanks for having us.
Thank you, everyone. Thank you, Bala. Thank you,
Okay,
Doug.
bye.
Thank you, Abu.
Thank you. Yeah. Bye-bye.
Bye-bye.
Bye.